Good morning. How are you today, grade 7? We want to continue our lesson 2 of chapter 14, energy transfer. We want to start with conductors and insulators. At the beginning, let's watch this video together. Try to focus to understand the meaning of conductors and insulators.
Jeff's family is having a nice time at the park. It is indeed a good day to have a picnic. His dad brings a grill and starts to barbecue chicken on the grill. Jeff runs to his dad to see if the barbecues are already done. He holds a metal skewer but immediately lets go because it is too hot. His dad uses oven gloves to hold the metal skewers without feeling the heat and shows Jeff the barbecues. The metal skewers are examples of materials that allow heat to flow. These materials are called heat conductors. Metals are good conductors of heat. The oven gloves do not allow heat flow to take place. These materials are called heat insulators. The non-metallic oven gloves are good heat insulators. Heat conductors are important in our daily lives. Cooking pans are made of metal to conduct heat easily and help cook the food faster. The base of the iron is made of metal so that clothes can be ironed quickly. The mercury inside the thermometer expands and contracts rapidly with slight changes in temperature. Heat insulators also play important roles in our daily lives. The walls of an icebox are made of polystyrene to maintain the coolness inside the box and prevent heat from entering the box. The handles of cooking utensils are made of wood or plastic so that they will not get too hot, allowing us to hold the utensils without getting burned. Woolen clothes and blankets trap a layer of air. The wool and air prevent heat loss from our body, thus keeping our body warm.
Okay, I hope that this video helped you a little bit to understand the meaning of conductors and insulators. Now, a conductor is a material through which energy can be easily transferred as heat. So the heat can transfer easily through the particles of this material. Insulator is a material that transfers energy poorly. So the energy or heat, when it transfers through this material, it takes time. It's a poor transfer energy material. Okay? Cooking pans are usually made of metal because energy passes quickly between the particles in most materials. These are examples for materials that are conductors: aluminum, steel, gold, insulators, wood, plastic, rubber. Okay, so these are examples for insulators, these are examples for conductors. Now, what about gases and liquids? Here we were talking about solids. What about gases and liquids? Liquids are poor conductors of heat. They are good insulators. Also, gases are very poor heat conductors because their particles are so far apart. To believe that or to understand it, look here. Carefully hold a safety match 1 centimeter away from a Bunsen burner flame. Do not put the match in the flame. You have to take it away to the right, off the left 1 centimeter. If a gas is a good conductor, the air, here we have gas, right, between the match and the flame. The air between the flame and the match should conduct heat and light or ignite the match. But this doesn't happen. So it means that air is a very poor heat conductor. It cannot conduct heat between objects from the flame to the match. So gases are poor conductors of heat, good insulators. Denser materials usually conduct energy better than less dense materials do. That's why solids, liquids, and gases, they don't conduct heat the same. Now we have just said that solids are the best, gases are the least. They conduct energy the least. Why? Because the particles are far away from each other. So when heat reaches these particles, they will vibrate, okay? But they will not reach quickly. The vibration will not reach the other particles quickly the same as solids. Look, when this one vibrates, direct the other one will vibrate, direct the other one will vibrate because they are in contact, they are very close to each other. That's why heat will transfer quickly. Here, slower, and here, very slow. Okay? Metals tend to conduct energy very well. We know this. Metals, they are good conductors. Plastic conducts energy poorly because plastic is what is uninsulated. For this reason, metal pots and pans often have plastic handles so we can hold them easily. Energy as heat moves through the plastic slower than it moves through the metals because plastic is uninsulated, metal is a conductor. Is it clear now? The second part of our lesson, something we call it specific heat or heat capacity. You can say specific heat or heat capacity. Focus please to understand the meaning of heat capacity or specific heat.
Hello, and welcome to another ADLC digital lesson. Today, our lesson is on heat capacity. If you've ever been to the beach, you know that the sun can really heat things up. So much so that the sand can get too hot to walk on. But you can always cool your feet off in the nice cold water. But it gets one thinking, why is the water so much colder than the sand when they are both getting heated by the sun equally?
So good. You go to the beach in summer, you stand on sand, you feel that it's very, very hot. You cannot stand on it. You just direct run to the water and you feel that the water is warm or colder than sand. Why? What is the reason? Now both of them, we have the same sun at the same time. So here's the sun. It heats them both at the same time with the same amount of energy. Why the temperature of sand you feel that is high and of water is low? Watch to understand.
And the answer has to do with heat capacity. Sand has a very low heat capacity. Water has a very high heat capacity. That means you have to heat up water an awful lot before the temperature goes up. Sand only has to be heated a small amount before the temperature goes up. So a small amount of heat from the sun can make the sand very hot. The difference between these two substances is huge. You could add tons and tons of heat to water, and it will resist temperature change. You can kind of think of water as having a large trash can for heat. You can put a lot of heat into the trash can before it fills up. Sand would have a very tiny trash can. It can't take much heat at all before the temperature goes up. Again, that is because water has a very high heat capacity and sand has a very low heat capacity.
Okay, so what is the reason? The reason is of heat sand needs just a small amount of energy. This is the type of material. The sand made of a material that needs only a small amount of energy to, and the temperature of it will increase very high very quickly. Water just needs small, sorry, water just, it will take a lot of energy, a lot of energy, a lot of energy, but the temperature of it will just increase a little bit. Okay? Why? Because of heat capacity. Water has high heat capacity, so it needs a lot of energy, a lot of time until the temperature increases a little bit. And low heat capacity. Low heat, it means just a small amount of heat and the temperature will increase a lot. Here, so here we have some questions. What's the difference between high specific heat and low specific heat? I explained the answer in the before. Does water have high or low heat capacity? We said high heat capacity, okay? Because it needs a lot of energy to increase the temperature a little bit. What makes a substance a good or a poor conductor depends in part on how much energy is required to change the temperature of the substance by a certain amount. So here in the example, when you put two different materials, a conductor and an insulator, like wood and metal, spoon and wood spoon, inside a boiling water, the same amount. After 5 minutes, for example, you come and touch both of them, you will feel that this one is very hot, this one is warm. Why? Now I know that this one is a conductor and this one an insulator, but also now both of them, they gain the same amount of heat, the same amount of energy, in the same amount of time. But what happens? The temperature of the metal spoon increased a lot. It means what? That metal spoon has a low specific heat capacity. Low specific heat. But the wooden gain the same amount of energy, but what? It has a high specific heat capacity. Means a lot of energy, and the temperature of it will increase just a little bit. Clear? Specific heat is a physical property which is represented in C. So the symbol for specific heat is C in solving problems. Okay, small letter C. Now, the definition of specific heat in physics, what is it? The amount of energy required to raise the temperature of 1 kilogram of the substance by 1 Kelvin. So, how much heat, how much energy I need to raise the temperature of 1 kilogram of this material, okay, by 1 Kelvin. This is the meaning of specific heat. Look at this table. We have different materials with different specific heats. For example, look at water here. The specific heat capacity for water is 4186. High specific heat capacity. Look at gold, for example, 129. Low specific heat capacity. So, it means that gold just needs a small amount of energy and the temperature of it will increase a lot. Water, it needs a lot of energy and the temperature of it will increase just a little bit. Okay? These are what? These are the values for C, specific heat for each material. Each value in this table is the amount of energy in joules needed to raise the temperature of 1 kilogram of the substance by 1 Kelvin. Specific heat can be used to figure out how much energy it takes to raise an object's temperature. So if I want to know the amount of energy I need to raise the temperature of this object, what I do, I multiply the specific heat, this one, the value from the table, it depends on the material. If I ask you about water, I will give you the specific heat for water. If I ask you about copper, I will give you the specific heat for copper, and so on. Times the mass of the object times the temperature change. I want to change the temperature of it from what to what? From 10 to 20, from 0 to 15, and so on. We will see. Now the unit for specific heat capacity is what? Joules per kilogram times Kelvin. You have to memorize the unit. Joules per kilogram times Kelvin. The unit of mass is what? Kilogram. Unit for temperature in this formula is Kelvin. But girls, if the question gives you the temperature in Celsius, you can use it in Celsius. Okay? No problem in calculations. But at the end, the unit is what? Kelvin. So no need to convert from Celsius to Kelvin. Okay, girls, please remember this note that if the temperature in Celsius or in Kelvin, you can use it in the formula without converting. But at the end, here, the unit for specific heat, it's okay, joules per kilogram times Kelvin. What's the unit of energy? We took it before, it is joules. Okay, good. Let's solve an example together. How much energy must be transferred as heat to a 200 kilogram? So how much energy they're asking for energy must be transferred as heat to a 200 kilogram. This is the mass of water. So they are talking about water. So I will give you the specific heat capacity of water. In a bathtub, to raise the water's temperature from 25 to 37. Let's see how we are going to solve this example. First of all, the givens, what I have, initial temperature is 25 because they said from. From always means initial. Temperature final is 37 because they said 2. So from 25 to 37, I want to increase the temperature from 25 to 37. So in the formula, I don't have initial and final. What I have, change in temperature. What does it mean? It means temperature final minus temperature initial. So I subtract them and I write the answer. 37 minus 25, the answer is 12 Celsius, or we said you can say 12 Kelvin. Look here in the question, I have Celsius, but I can solve normally. No need to convert. So the change in temperature that I'm gonna use it in the formula is 12. Mass is given 200 kilogram and the specific heat capacity of water, here is it. How we're going to solve? First step, we write the formula. Second step, we substitute 4186 C, mass 200 kilogram, and the change in temperature is 12 after I subtracted these two numbers, don't forget. So you multiply them all, you get the answer in joules. Okay? Is it clear? Just solve it step by step. Don't forget the first step to subtract the temperature to get the change in temperature. Okay? Good. So that's all for today, girls. I finished explaining this part for today, but you have practice on page 486. You have to solve it as a homework. Two questions, they are very direct, but focus, please. You have to do one thing before you start solving. Don't forget to convert the mass from gram to kilogram, because in the formula up here, I told you that the mass has to be in kilogram. So don't forget to convert by dividing by 1000. I helped you a lot. So just solve. Now see specific heat capacity. You have to go back to the table. You have it in your book and here in the presentation. Iron, you will go to the table and you check iron. What is the specific heat capacity for iron? You take it, you use it here. Here we are talking about water. You take the specific heat capacity of water. How can I help you more? Just you want me to solve? You have to solve it. I helped you a lot. The second thing I want you to do is to copy this chart on your copy books or on your book or on a paper and fill the empty places. Okay, with the correct answer. The last thing I want you to do is to solve the worksheet. I'll send it to you now. Okay? Good luck, girls. Thank you.